I recently published a blog post introducing something called Choria Scout. Scout is infrastructure to build monitoring pipelines on top of Choria infrastructure. Choria, as you may know, is a message-based framework for building orchestration tools, remote execution systems, databases for extracting information from your nodes, distributed RPC systems with a very strong focus on security and scalability. Out of the box, we very easily support 50,000 nodes managed by Choria, and we want to take these abilities and these features and build a monitoring platform on top of that. Now, initially, we released the ability for Choria to run Nagio-style checks. In other words, they have a basic exit code API that says, okay, unknown, critical, or warning. And we will also add the ability to run GOS checks, which is a kind of a node-based integration tool, testing tool. And these run completely autonomously, even if the machine is disconnected from the network. There's no central orchestration required to make them run. They will just run forever, and they publish their data using open standards cloud events. It also supports remediation. So if it finds something is wrong, you can hook into it commands that says remediate, fix problems, try to fix them at least if possible. And this is quite a nice piece of infrastructure there to build these tools. It integrates with Prometheus, and so if you use Prometheus node exporter, you can extract a bunch of data. You can expose the individual check statuses to your Prometheus infrastructure from where Grafana can draw them. Alert Manager can send alerts. Integrates with Slack and VictorOps and all this kind of stuff. And that's all there today in Network. Now we want to build a small distribution of Choria focused on this problem of monitoring. It doesn't have the remote execution and doesn't have some of the other things that Choria does because not everyone use that, or people they just don't care for it, or people would rather use other companies' tools. That's fine. We don't care. Or you just want to have a very lightweight monitoring agent that runs next to your Kubernetes pods, maybe in a sidecar, and that's what we're trying to build. Now, monitoring tools, of course, have to be quite easy to get going. So here we have a single binary Scout. It's 20 megabyte big. I have a JWT that tells this binary how to go and provision itself. In other words, where to get certificates, its own TLS certificate and so forth, and where the shared central components are and this kind of thing. And it will get that configuration and sets and all this kind of stuff with no configuration management involved. For the purpose of monitoring, I support tagging a machine by type. So here I have common. All machines will get these checks. I can tag the machine as web server or database or whatever, some kind of a microservice, and it will automatically obtain those checks. And we'll look at that in a little bit. It can obtain from the network, from the Choria network, it's checks to run for the tags, what those checks are, what commands to run, how frequently to run them, and so forth. And also node-specific overrides. It says on this particular node or this particular kind of machine, you want to have a different parameter per check. So it supports all that kind of stuff. Let's have a quick look. So I'm going to start Scout. It has no configuration, it has no TLS, none of the things that you would want, but it has no checks defined. All it knows is these tags, and it has a JWT that provisions it. So this is very much in line with how you would think of IoT devices. They're all the same, many of them, and they auto-provision of your network and have a management framework to look after them, and that's very much what's happening here. So here you can see that it started up. It already has some checks, certificate check and a swap check. And if we have a look here what happened, we can see now we have a configuration file, the normal Choria configuration file. But this was generated by the system, so it's not one that you had to go write yourself or create using configuration management. We have two checks defined, cert and swap, and that comes based on the tag. And we have some overrides. It tells it, maybe for this machine, there's a different level of criticality around swap. And this will now run these checks. It will publish the data. It will do all these things. In the background, there's the shared infrastructure running on Kubernetes, so I can maybe have a quick look at that. Now you don't need all of this, and I'll explain a little bit about how this all changed. So we have 3 brokers here. They're a hosted version of NATS. This very, very fast, very lightweight, embeddable message broker written in Go. Full disclosure, I'm consulting to the NATS business, and so I'm quite involved in its creation. You don't need to run free. I'm running free here just to do some high availability and test my clustering capabilities. A single one of these things running on like a $40 a month Linode can quite happily manage and monitor 50,000 nodes managed by Choria. We have a thing called Stream. This is a new component that we're working on as part of NATS called JetStream. This is also managed within Choria, so you don't see the JetStream process running. It's just you enable Choria streaming feature and it happens. Today, JetStream doesn't support clustering, but it will, and soon these free servers will automatically provide the streaming capability. Underneath is a PVC for resilience and storing metadata. The stream stores, the events and the messages being published and the check statuses and all of this kind of stuff. But also the configuration is actually stored in there. We'll see that in a little bit. I have a provisioner that takes care of onboarding the new machines. If you're going to make the configuration by hand, it's not necessary. And we have AAA service. This provides authentication, authorization, auditing for access to the system. And so, for instance, I could ask this particular server up here running Scout to immediately now do a health check of the swap. And you do that via an RPC call. The RPC call would need to be authorized and authenticated. And you can integrate that with SAML, you can integrate that with Okta, you can give this thing just files with usernames and passwords. It's quite a flexible system, and you can integrate it into literally anything. I recently integrated this into a company's homegrown SAML-based SSO system, so that on the CLI you log in with the same credentials. Supports all of that. And that's it. For Scout, these components will all run in one binary, one Docker container. There'll be one Helm chart to just deploy them, and it's the same binary that goes on all of the machines. So it's really easy to deploy, very minimal dependencies, and you're not going to run 4 or 5 processes. You'll just have one process. Of course, if you want HA, you would have 3 instances. Now, this checks, as you can see, it's running, it's checking the things, it's checking certificates, all this kind of stuff is happening. Yeah, of course, I'm checking swap and cert. I just want to show what happens if I drop one of the things. So, as I said, we store the data in our streaming server, which is NATS JetStream. I haven't made UIs yet for creating these things. I will soon, once the model is completely solid and I know it works well. But we put the data into the stream. It's stored there forever, and it knows that all machines with this common tag now is only checking swap. You can see that the cert check is being shut down on this machine, and if I look at checks, it's only the swap one being done. If I put it back, suddenly it's getting monitored again, and the check is back. And so this is the kind of system we're building. It will be a purpose-built Choria infrastructure using all of the provisioning, all of the high performance, high throughput messaging to build a monitoring system that's open. It's completely Apache 2 built. All components of this Apache 2 license, including the packaging, and it integrates really easily with other technologies like Prometheus and fully cloud native basis. You can store that it's running on Kubernetes. Yep, that's just a little preview on what we're working on. And if you're interested in playing with this, get in touch. Thank you.